Hi everyone, welcome. We are now looking at further examples on Kirchhoff's law using this kind of format. The example reads, for the bridge network shown in the figure below, determine the currents in each of the resistors using Kirchhoff's law. Remember, we have said in Kirchhoff's law what you need to do, you need to identify the loops. The loops will be the guiding factor. So in this particular case, as it is, you can see we're having three loops. The first loop will be if you move from this point, we can talk of this loop. So this one becomes our loop 1. Loop 1. We can also take this one to be our another loop. Let us say that is our second loop, whereby we will say if this is our first current, the current branches like that, and another one takes this direction. Another one takes this direction, such that if this was our I coming, then we will say our I1, we will have our I1 taking this side. Remember, Kirchhoff says that upon reaching the junction, current will split into the number of branches that you have in. So in this case, we have said let this current reaching this point, the first part to be I1. So the one passing here will be I, total current, minus what is passing through this point. Basically what I mean, if this was 9 amperes coming, and we have said let 3 amperes to be flowing through this point, then the current moving through this point will be 9 minus 3 to be 6. That is where we are saying we are not going to use numbers, we are using letters. If the total current is I, we are saying let I1 be the current flowing through this branch, then the current flowing through this other branch will be the total current minus the one that has passed through this junction. Then this one now becomes our loop 2. That is our loop 2. We also have our third loop. Our third loop will be this one. We are having the third loop. That is our third loop. And the next thing that you need to know is we need to label the currents that are flowing in this branch. We can also say if this is our I1, this one to be our I2. So that now this becomes our I2. Again, we also need to determine the current passing through this other branch. Basically, we have said the current I comes to this point are splitted into two, I1 and the remainder will pass through this point. We have also said this I1 will come, once it reaches this point, junction, it will also split. Part of it will move through this resistor and part of it will enter through this other resistor. So we are saying the part going through this resistor to be I2. So the current passing through this other resistor will be I1 minus I2. Will be I1 minus I2. That is now the current that is passing through that other resistor. So this is the current that is passing through this resistor, I1 minus I2. I1 minus I2. So having labeled that, it is also clear that whatever that is passing here, remember we have said I1 minus I2 will be passing. So this current will be reaching this junction. This one will also be reaching this junction. If you want to know the current passing through this one, you can now sum up those currents. And if you sum up those currents, you will realize that, so when this current coming and this one is also coming, so it means whatever that is going through this point, the current that will be going through this point, because we have said this one will be coming towards this junction, this will also be coming to this junction. So the sum of the currents coming to this point will be equal to the sum of the current that is leaving. So meaning the current across the resistor 3 will be equal to I1 minus I2, this one, plus the current which is coming also to that junction plus I1 minus I2. If you sum up these two, open the bracket, I1 minus I2 plus I1 minus I2. You can see that is there anything that is cancelling? We can check. We can check and see whatever that is cancelling out. We have said this is I minus I1. This is I1. That is where we had an issue. Let us correct. This is I minus I1 and this is I minus I1. So you can see I minus I1 plus I1 is 0. So whatever that is remaining is I minus I2, because these and these will cancel. So the current that is passing through this resistor will be I minus I2. That is the current that is passing through that particular point. So you need to analyze your circuit in such a manner. You need to know the loops you are having, and you also need to identify the currents that are flowing in every branch, so that they will make your calculations easier. So having said that, we can now extract the loops and deal with them. So maybe I can start with the first loop. I can use this as my first loop. So I can redraw the circuit and say my first loop will take this form. Takes that form, then like that, and I've been told this is 54. This is 54 volts. This is I, which is 8 amperes. I've also been told the current flowing here is I1. I've also been told the current that is flowing in this other branch is I2. The current passing through this resistor is I2. So now, after you have identified this, and we have said this is our first loop, we can now determine the equation for loop 1. Equation for loop 1. So in this case, remember, in the first case we have applied Kirchhoff's current law. In this case we shall be applying Kirchhoff's voltage law, where we will say the total voltage supplied will be equal to the voltage drops. So this voltage is equal to the voltage drop across this plus the voltage drop across this. Remember, this is 2 ohms and this is 11 ohms. So basically it means we will be having this one will be equal to 2. This is the resistor multiplied by I1. The voltage drop here will be equal to this current I1 multiplied by the resistance. The voltage drop across this resistor will be equal to I2 multiplied by 11. So plus 11 I2. So that forms our first. So that one forms our first equation. This one forms our first equation. We can also look at another loop. Let us take loop 2. If you look at loop 2, I can redraw it again. Look at loop 2. We're having this. We are also having that. And we're also having this. Remember we said the current through this resistor is I1 and this resistor is 2 ohms. The current flowing here is I1 minus I2, I1 minus I2, and the resistor there was 32 ohms. The current flowing here, the directions are very important. Directions of the currents are very important here. This is I minus I1. And this resistor is also 14 ohms. So once you identify that, we can now write equation. Equation for loop 2. Equation for loop 2, remember, there is no voltage source in loop 2. So we will assume the voltage is equal to 0. So 0 will be equal to we can begin here. The voltage drop across this resistor will be equal to resistance times current, I1. Voltage drop here will be equal to the current times the resistance. So 32 multiplied by the current, which is I1 minus I2, plus the voltage drop here. Remember, our loop goes this direction. So meaning, it will be, so because we'll be moving in the negative direction, remember the current is flowing in this direction, our loop is going in the opposite direction. So we need to attach a negative here. So minus into brackets I1 minus, so this current will be, we will be having a negative here because the loop is moving in the opposite direction with the flow of the current. That is why I've put a negative here. Then I can attach 14. If you open the brackets, you will get 0 will be equal to 2I1 plus 32I1 minus 32I2 minus, remember this 14 can come here. This is the same as writing 14 here. Plus minus 14. It is the same. And a plus times a minus, you will get a minus. I'm doing that to make our work easier as we open the bracket. So 14 times this, you will get minus 14i, minus minus, you get plus 14i1. Let us now look around and see what is cancelling for simplification purposes. You can see we having I1, we have I1 here, and we have I1 there. So this is 34 plus 14. That is 34 plus 14. So 34 plus 14, you will get 48. 34 plus 14, you will get 48. So meaning this becomes 0 is equal to 48 I1. What about this other one? This one becomes minus 32 I2. And then we are also having an I there, the total current. So this becomes minus 14i. But remember, what was our I1? We know the value of I1. Sorry, the value of I. Remember, this I is been given as 8. So we can simplify that. 0 is equals to 48 I1 minus 32 I2 minus, so we want to replace 14 with 8. So 8 times 14, you will get 8 times 4 is 32, 11. You will get 112 as that value. And you can see now we can simplify this equation by saying If you bring this one to the other side, you will be having 12. 112 is equal to 48 I1 minus 32 I2. So that happens now to be our second equation, but you can simplify further. If you divide both sides by if you simplify, you divide by 16. If you divide by 16, you will get this is 7, because 16 times 7, this is 42. That is you'll be able to get, that is 7. This becomes I3, 3I1 minus 2I2. So this forms our second equation. Of course, you can move ahead. And get the third. You can move ahead and get the equation for the third loop, but the two equations are enough. You can formulate two equations. They are enough for getting the values. So if we move ahead, we can now be able to combine the two equations. You will get 54 is equals to 2I1 plus 11I2. 7 is equals to 3I1 minus 2I2. You can use elimination, you can use substitution to solve this equation. You can use elimination or you can use substitution to solve this equation. So if you use elimination, when you use elimination, remember you can say, let us use elimination, whereby you interchange this and this. Maybe you can say this is 3 and this is 2. You interchange the coefficients of the unknown that you want to do what? To eliminate. So if you multiply across, you will get this becoming 54 times 3. You will get this one becoming 162 is equals to 6I1 plus 33I2. If you multiply this, you get 14 is equal to 6I1 minus 4I2. So if you subtract, you will get minus 14. This gives us 148 is equals to, remember this becomes 0. If you subtract, this becomes plus 37. Minus and a minus, it becomes 37. So if you divide by 37, so this is I2. So if you divide by that 7, so meaning our I2 will be equal to 148 divided by 37, which is equal to 4 amperes. So you will have determined the current I2. What is the current I2? The current passing through this resistor. Once you have reached there, you can move ahead. And clean this part. Once you are there, we now want to get our I1 from this particular equation. You can pick any of the equations. Remember our equation 1 was this. Our equation 2 was this. Our equation 2 was 7 from this one. 7 is equal to 3I1 minus 2I2. If you want to get I1, you can substitute the value you have gotten. You can substitute the value you have gotten, so that you have 7 is equals to 3I1 minus 2 into, what is I2? I2 is 4. So that now 7 is equals to 3I1 minus 8. If you bring this one to the other side, you will get 15 is equal to 3I1. 15 is equal to 3I1. So that now, therefore, our I1 will be equal to 15 divided by 3, which is equal to 5 amperes. So that is the current I1. Remember, we have now determined I1. We have also determined I2. We know the current passing here. We also know the current passing through this one. If you want to get the current passing through this point, it will be equal to, remember this will be 8 minus I1, which is 5, meaning we'll be having 3 amperes passing through that branch. If you want to determine the current passing through this branch, it will be I1. Our I1 was 4, and our I2 is 4. So meaning it will be 1. So this will be the same as 5 minus 4, which is 1 amperes. Huh? So meaning the current passing through this is 1 amperes. You can move ahead and determine the current passing through this point. This will be 8 minus our I2 is 4, meaning this one will be 4 amperes. So that is basically how you analyze this particular circuit with the current flowing in every part. And we are going to stop at that point. But most importantly, what I've said is the first step you need to take is to analyze the currents. And make the loops. After you make the loops, you make the equations and you solve them. So we will stop there. Thank you so much.